I tricked you. Just a new video for this stuff here because I wanted to go over it with you rather than just popping the answers out there. If you wanted to see the answers, just kind of zip to the end of this video because this is we're only doing this one thing in this video. Then we'll go to the next lesson in the next video. Talk about trigonometric ratios, part B. But part A here, the last of this video, let's just draw these out. So changing it quickly to degrees. So I'm going to times it by 180, divide by pi. So I get 300 degrees right about there. Okay, so all of that. Remember what we did before. We put into degrees so I can read it, so I can draw it nicely. But I answer and write everything in radians because it's radians in the question. Okay, so to find the reference angle, I'm going to take the whole circle, minus out that reflex angle that I have there. So that's going to be 2 minus root 3 over 2. So that's going to be 1/3. So this reference angle here is going to be pi over 3. You got to realize your reference angles, as long as these are on the unit circle, are going to be either pi over 3, pi over 6, or pi over 4, 0 or 90, or it's going to be 30, 60, 45, or 0 or 90, or pi over 2. This is quadrant 4. Point down there because this is 60 degrees. The long side here, the y is the longer side. So the y's are the longer side. So that means that is going to be the root 3 over 2 side. And it's going down, so that's the negative side, that's positive. And we're talking about sine here. Sine is the y value, if I remember correctly. Cos theta, sine theta, x, y. So negative root 3 over 2. So I'll go back up here to a different question. Yeah, it's very similar to this one here, but they were backwards, yeah. Okay. Where'd you go? Come on, pop up. Wow, there it is. Okay, just took a while to pop back up. 210, that's nice. It's already in degrees for us, so 210. Right about here, it's past 180. 180 is right here. This is a 30-degree reference angle then. Should probably draw the whole angle. So 210, 30 degrees reference, which is 30 degrees. If you want to put that in radians, you can. If you like radians, it's great. We're quadrant 3. 30 degrees. So that means the y value is the shorter side. That's the sine. So sine 30 is a half. We already knew that. So that's going to be a half. It's going down. It's negative. And the x is also negative here. So negative root 3 over 2. And we're talking about cos. Cos is the x value. Both happen to be the same. Both happen to be negative too, which is nice. Secant. Oh, secant's upside down. Okay, so this is going to be a little bit different. Drawing the angle, reference angle, all that stuff's all the same. So I'm just going to quickly do that. So this is 240. I think we did this one before. 240, so this is 4 pi over 3. This is pi over 3 for the angle. You notice that they're both over 3. These are both over 3 up there as well. You notice that that's kind of a pattern. If my angle's over 6, my reference angle's over 6. My angle's over 3, my reference angle's over 3. It's a very good pattern, something useful. Okay. That means the y value is the longer side here because that is a 60-degree angle. It's in quadrant 3 as well. So the y is the longer side. Both negative because we're in quadrant 3. Everything's negative in quadrant 3. Secant. Okay, so secant is the same as 1 over, here, I'll write this down here. So this is 1 over cos 4 pi over 3. So First of all, let's find out what cos is. Cos 4 pi over 3. Cos is the x value. So this will be 1 over the cos value. So this is going to be 2. Oh, negative 2, I should say. Stop. Negative 2. There you go. Cool. Cotangent. So this is going to be 1 over tan 135. You notice the angles don't change. I'm not flipping anything over with those. So 135 is in this quadrant. If you do the math on that, this ends up being 45 degrees. We're in quadrant 2. Because we are 45 degrees, we're both 1 over root 2, or 2 over root 2, whatever you want to write. And the x is negative, but the y is positive. Okay, now we're going to go 1 over tan. Now tan, okay, I should probably put that over here. So tan is going to be y over x, but both the numbers are essentially the same, but one's negative, one's positive. X is negative. So this ends up being negative 1. So this is 1 over negative 1, which is negative 1. Cool. All else fails, just plug them in your calculator. If it pops out a nice number, that's the nice number you use. 2 over 3 is going to be in this right over here. 2 over 3. 2 times 180 divided by 3 is 120. That makes this reference angle pi over 3. So remember that pattern there. This is over 3. That's over 3. This is a 60 degree. And we're in quadrant 2. We have something similar to 60 over there. So it's 1 over 2, root 3 over 2. But x is negative, but the y is positive this time. And we're doing cos. Cos is x. So this is negative 1/2. Oh, I gotta fix that all up. I messed up. Do you see where I messed up? Reference angle is probably still gonna be the same reference angle, but no, it's a stupid thing. Sometimes that doesn't work very well. I forgot to go the negative way. So my reference angle is pi over 3 still. It's still 60 degrees. But we're in this quadrant because we're negative 120 this time. This is negative 2 pi over 3. My bad, sorry. Reference angle still positive number. We're in quadrant 3 this time. What are we doing? 60 degrees, yeah, so 1/2. What do we have here? 1/2 root 3 over 2. We're both negative, okay. And cos, what ended up just being the same thing. Cos is negative 1/2, so we got left out there. Cos is your x value. So tan. Now to be coterminal, if you land in the same quadrant, on the same arm, then you have the same ratio. So what I'm going to do is I'm just going to find a coterminal angle to tan 690. So I'm going to subtract 360 from that. I'm going to get 330 instead. Okay, so I'm going to draw 330. So there's 330. The reference angle is 30 degrees. You want to put that into, don't see why you'd want to, but into radians. Why not fill that in? Okay. Quadrant 4, 30 degrees, which means my y value is the smaller number. It's also negative because it's going downwards. X value is root 3 over 2. Awesome. And we're doing tan. So remember, tan is underneath my picture here. Is y over x. So y is negative 1/2. I don't know where I was looking. X root 3 over 2. Take the reciprocal, so negative 1/2 times 2 over root 3 negative 1 over root 3. That's good. If you want to take the rationalize that, you can rationalize that to be negative root 3 over 3, but I don't see why you'd want to do that. If you have questions about rationalizing, come ask me in the Google Classroom there. 3 pi is more than 2 pi, so this is beyond this full circle. So what I'm going to do is I'm going to minus 2 pi from that. So this will be the same as cosecant pi, which is 90 degrees. Remember, cosecant is sine, so this is the same as 1 over sine. You can just find all that on your formula sheet. So this is going to be pi. So pi is 180 degrees. So right there is where my terminal arm is. So that's going to be pi. You can do 3 pi as well. You can draw that, but it ends up being the same place. My reference angle is going to be 0, not 0 degrees, but 0 rads, right? So you just write 0 there. I'm in between. So a quadrantal angle again between 2 and 3. My point here is negative 1, 0. Assuming that these are all in the unit circle. Sorry, I forgot to mention that. And 1 over sine. Sine is my y values. So 1 over 0, undefined. That's it, undefined for that one. There's no actual real answer for that. Negative 1/3 pi, so I'm ending this quadrant down here. Negative 1/3 pi. 60 degrees, quadrant 4. Boop, boop. 60, that means my y value is the longer side. So these are my two numbers here. And it's going down, but over to the right. And we're doing tan. Let me just do a tan. Well, I had a tan for a 30. This is a tan for a 60. Okay, so it's going to be y over x. Take the reciprocal, multiply it. Negative root 3 over 1, but you just write down negative root 3 and you're fine. Okay, so there are the answers. I was going to zoom out. I didn't like that too much. There it is right there. Oh, I can't quite zoom out. So look at the bottom and then look at the top here. There are the answers. You can just pause at any point. Okay, so we are going to the next lesson. The next video. Continue on with these ratios here. But this time we're going to be a bit more about solving them, solving these equations using the ratios, exact values, and solving for angles and stuff too. Okay, I'll see you in the next video. Bye.